This video, we're going to talk about reflections across the x-axis and the y-axis. If we have a reflection that looks like this, we're calculating the opposite y value, and that's a reflection across the x-axis. If we have a reflection that looks like this, we're calculating the negative x value, the opposite x value, but keeping the y value the same. So that's a reflection across the y-axis. I'm going to use Desmos again to help visualize this for these problems. So let's start off with y equals x squared, and we're going to reflect it across the x-axis first. And you'll see that all of the x values remain the same. The y values become the opposite y values. So 0, 0 stays the same. 1, 1 changes to a 1, negative 1 right there. 2, 4 becomes 2, negative 4, and so on. Because y equals x squared is an even function, then when we try and have a reflection across the y-axis, it's not going to appear to do anything. Red function and blue function are going to lie on top of each other, because what happened is this point that was here at 1, 1 reflected over here to this point that was at negative 1, 1. And this point that was at negative 1, 1 reflected over here to 1, 1. And so on, that right-hand side reflected to left-hand side and left-hand side reflected to right-hand side. And we see that it appears that the red function and the blue function are lying on top of each other. That's exactly what we would have expected if we would have done the arithmetic over here, because when you square a negative, you would get a positive, and so we wouldn't notice any difference. Let's try again now with another function that is an odd function. There you go. Y equals x cubed. And we're going to make this one a negative x cubed. All of our positive y values become negative, and all of our negative y values become positive, and we have a reflection across the x-axis. If you would hold a mirror on the x-axis, what's in red would be reflected and become what's in blue. Let's try that reflection across the y-axis now with this. Because it's not an even function, we should be able to see a difference here. But it doesn't look any different to us than what we just did with the negative on the outside, because if I take a negative times a negative times a negative, I'm going to get a negative. And so those look exactly the same to me, but I did it in a different way, because instead of taking this red point and reflecting it across the x-axis to get this point down here in blue, I instead took this point here that was 1, 1 and reflected it across the y-axis to get that point over there that was 1, negative 1. This point in blue over here that's 1, negative 1 came from this point over here now that's negative 1, 1, and it was also reflected across the y-axis. So let's see if maybe we can find a function here that's going to help us be able to see the difference. This is going to be a good one. So let me change my characteristic points. A second here, we're going to talk about the square root function. And we're going to pick perfect squares for our x values. There we go. And I'm going to put in those same characteristic perfect squares for my x values down here. I'm going to calculate a negative square root of x. So again, we see that the y value has changed sign because the multiplication was on the outside with y. See that? Now let's try it the other way with the multiplication by -1 on the inside with x. And I'm going to have to change all of these, the sign of all of these. And you'll see what happened here, that there was a reflection across the y-axis. The 1, 1 reflected and became -1, 1. 4, 2 reflected and became -4, 2. 9, 3 reflected and became -9, 3. 16, 4 reflected and became -16, 4. So there's a function that we can see the reflection happen across the x-axis or across the y-axis, and they don't appear to be similar to each other. Let's try the absolute value function now. This is another even function. So we would expect it to act a lot like x squared did, where we won't see a reflection across the y-axis. Let's fix these characteristic points for a second. Let's fix these characteristic points. Okay. And you're going to see that, again, the y values have become negative when we go from red to blue. All right. Let's try that now by putting the negative on the inside. And we're going to see that blue is going to lie on top of red, again, because it's an even function. So remember, our definition of an even function told us that if f of -x was equal to the original f of x, just like we're seeing right here, that was an even function. And let's recall that an odd function was when f of -x was equal to -f of x. So we wouldn't see any difference between the reflection across the y-axis and the reflection across the x-axis. They would look exactly the same to us if it's an odd function. Just to go back to something that we talked about in a previous video. Now let's deal with some reflections that also have some translations in them, some horizontal and vertical shifts. So let's go back to y is equal to x squared. And let's find the graph of negative quantity x minus 2 squared minus 4. And we've shifted all of the x values 2 to the right. So we'll go ahead and do that so we can see what's happened with the points. And the vertex that was at 0, 0 was shifted to a +2, -4. And we multiplied all of these changes over here by a -1 before we shifted them down 4. So let's go ahead and go 1 to the right and 1 down, 1 to the left and 1 down, 2 to the right and 4 down, 2 to the left and 4 down. So opposite sign for all of these changes here. Now let's try to have a multiplier in front of this, and this is going to be x plus 1. I have to fix my x values for that. And this is going to be minus 4. So we're going to be centered at -1. And that makes this a -2 and a -3. That makes that a 0 and a 1. We're going to shift 1 left and 4 down. And there's our new vertex. Now we have multiplied all of our y values in our original by -2. So when I go 1 right, I should go 2 down. And I do. When I go 1 left, I should also go 2 down. And I do. When I go 2 right, I should go 8 down. And I do. And when I go 2 left, I should also go 8 down. And I do. See how that works? So we don't have to actually calculate all of these. We just need to be able to find the vertex and be able to put some of the characteristic points that we know based off of the transformation. We don't really need to make all those calculations, and then we can draw our shape. All right, that was number 35. Now let's do a similar problem or two about guaranteed points on the graph. So we know that the 0.24 is on the graph of some function that we're calling f of x. And we want to find what point is guaranteed to be on the graph when we have a reflection across the x-axis. So a reflection across the x-axis is going to give us the opposite y value for the same x value. So that guarantees us the 0.2, -4. If we have a reflection across the y-axis, that gives us the opposite x value, but with the same y value. So that's going to guarantee us the point -2, +4. It didn't ask us about a reflection across the origin, but if we think about a reflection across the origin, we had the 0.24, we would be guaranteed the point -2, -4, since we would change both x and y. All right, that's it for this video. We'll come back next time and talk about a different topic, but this wraps up our basic discussion of transformations of functions. Have a good day.